Hi, welcome to my video on primary trig ratios part 3. Being part 3, we will have some different style questions. Let's do some examples. Triangle ABC has angle C 90 degrees. The cos of A is 3 over 5. Find the sine of A and the tan of A. Well, let's draw a right triangle because we have angle C is 90 degrees. The triangle is angle C is 90, so if we make that a 90-degree angle, we have to put C right here. So I can put A or B here. So let's put A here and B here. So there's the triangle with angle C 90. The cos of A, what happens? SOHCAHTOA, SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So if the cos of angle A is right here, cos is adjacent over hypotenuse. So what we have, if this is the hypotenuse, HYP, we have angle A, so this is adjacent, and this side is opposite. So that means if cos A is 3/5, so A over H is 3, A is 3, adjacent is 3, hypotenuse is 5, and that allows me to get the sine, cos, and tan, but I have to use the Pythagorean first. So C squared is A squared plus B squared. C is the hypotenuse opposite the right angle, that's 5. A is 3, and we can call this side X, or we can leave it as B, whatever you want. 5 squared is 25, 3 squared is 9, X squared. So 25 minus 9 is X squared. X squared, 25 minus 9 is 16. So X equals the square root of 16. So X is equal to 4. So let's put a 4 right here for X. So the sine of A, sine is opposite over hypotenuse, O over A. So the opposite side would be 4 over hypotenuse 5. The tan of angle A, tan is opposite over adjacent. So the opposite side would be 4 over the adjacent side of 3. So note, we were given, draw the right triangle, fill in hypotenuse, adjacent, opposite for whatever angle, and work it through. So just to reverse in what we've done before. Practice means pause the video and work each of these one at a time. So here we go. Triangle PQR has angle P 90 degrees. The tan of R is 5 over 12. Find the sine of R and the cos of R. And again, we have a triangle. And P is 90 degrees, so let's put that in. P is 90 degrees, so I can say that this is a Q and this is R, or this is Q and that's R. It makes no difference as long as you put P 90 degrees. And SOHCAHTOA again is S-O SOHCAHTOA. And we have the tan is opposite over adjacent, so that's opposite over adjacent. The tan of R, so R, this is the hypotenuse. In relation to R, this is opposite, and this is adjacent in relation to R. So tan is opposite, which is 5, over the adjacent, which is 12. Again, we need the hypotenuse to work out the sine and the cos. So C squared is A squared plus B squared. C is the hypotenuse opposite the right angle, and we don't have that, so we have to put an X there. So C is X squared, A is 5, and B is 12. So x squared, 25. 12 squared, 144. So that adds up to 169. So x is the square root of 169. So x is 13. So let's put a 13 there. So we have to find the sine of r. So the sine of r, sine is opposite over hypotenuse. So in relation to r, opposite is 5, hypotenuse is 13. And we have to work out the cos of r. The cos of r, cos is adjacent over hypotenuse. So the adjacent side in relation to r is 12, and the hypotenuse is 13. And that's the two answers. And number 2, we have a triangle DEF, has DE perpendicular to EF. The sine of F is 15 over 17. So we have to work out the cos of F, the tan of F, and the sine of angle D. So what we have is, here we go. Let's draw a triangle again. And it says that DE is perpendicular to EF, so that must be angle E right here. And that could be the D, and this could be the F. But angle E is the intersection of the two sides right here. So DE is perpendicular, so that's a right angle. Perpendicular lines form right angles. And it says that the sine SOHCAHTOA is sine SOHCA, C-A-H-TO-O-A. And so sine is opposite over hypotenuse, so it's opposite over hypotenuse. And what we have is that we have in terms of F. So in terms of F, this is the hypotenuse opposite the right angle. The sine of F, so that's opposite. And that's adjacent in terms of F. Okay, here we go. Now, so what happens? We have the opposite side is 15. The hypotenuse is 17. And we have to work out the third side. So again, c squared equals a squared plus b squared. And c is the hypotenuse opposite the right angle, so that's a 17 squared. A is 15. And the unknown, let's call it x, so b is the x. So what is 17 squared? 17 squared, I work it out on my calculator, becomes 17 squared is 289. 15 squared is 225 plus x squared. So 289 subtract 225 equals x squared. So that gives me 64 equals x squared. So x is the square root of 64. So x equals 8. And just to check the 17 squared again, just to make sure, 17 squared is 289. Everything is okay. So this is 8. And we have to work out the cos of f. Cos is adjacent over hypotenuse. So in terms of f, there's f. The adjacent is 8. The hypotenuse is 17. The sine of f, or we could work out this. Okay, sorry. Let's do the tan of f. The tan is opposite over adjacent. So f is opposite is 15, adjacent is 8. And we have to work out also the sine of angle D. So I could draw a new triangle like this, and D is here. So if I have D there, so that's a 17, that's a 15, and that's an 8. In terms of angle D, then this is opposite. This is the adjacent, and this is always the hypotenuse. So the sine is opposite over hypotenuse. So in relation to D, opposite is 8 over the hypotenuse of 17. And we have them all worked out. Just different questions. Let's continue. Now we have a different style question, but it's still related to what we just did. So what we have here is that we have a triangle, and I'll put the triangle here, and we have triangle STR where angle T is 90 degrees. So T is 90 degrees, and we can put, if T is 90, we can put S here and R here, it makes no difference. And sine, SOHCAHTOA, SOHCAHTOA. So sine is opposite over hypotenuse. So 4 in relation to R. R is opposite. So we have R opposite is 4, hypotenuse is 5. Now we should, if you think about it, look at memorizing some of the trig Pythagorean triples, and we have a 5 and a 4. You can very quickly see that's a 25. Subtract 16 is 9. Square root of 9 is 3. So I can, without manipulating, I could go c squared equals a squared b squared and work it out. This becomes a 3. But if you memorize some of them, like 3, 4, 5, and there's a 6, double it 6, 8, 10, 9, 12, 15. Then there's a 5, 12, and 13 that you should memorize. Several triples you should memorize more, makes it easier if you don't have to work them out then. So we have to do, here we go. Now, find the value of each as a fraction in simplest form. So notice what we're doing now, right here, is that we're working out PEMDAS, PEMDAS, or BEDMAS. So if you keep that in mind and working out these, we do the order of operations. All this calculations on all of these questions is obeying the order of operations. So here's the triangle, and this is the hypotenuse, HYP. This is the opposite in relation to R now, so that's opposite, and that's adjacent. So here we go. The cos of R. Cos is adjacent over hypotenuse. In relation to R adjacent is 3. Hypotenuse is 5. So that's 3 over 5. R, tan R, that's a multiplication sign. So the tan of R is, tan is opposite over adjacent, so it's 4 over 3. So we're multiplying these. The 3's cancel to give us 1's. 1, 1. So I get 4 over 5. Now I have this one, and I have the sine of R. The sine of R is automatic, was given to us, so that's a 4/5. Divided by, we know what the tan of R is because it's here. So it's 4 over 3. I don't have to work that out again. So I'm dividing fractions, so that's 4/5. When I divide, I multiply by the reciprocal of 3 over 4. And notice that the 4's cancel out. So I get 3 over 5. C, I'm working with S. So here's S. Sine is opposite over hypotenuse. So that's a 3 over 5. There's S. Opposite is 3 over 5. Plus the cos of S is, cos is adjacent. So in terms of S, this is the adjacent side. This is the hypotenuse. So that's 4 over 5. And we're adding. When we add fractions, we have a common denominator, which is 5. So we add, we get 7. So that's 7 over 5, or 1 2/5, but let's leave it as a fraction. We could say 1 2/5 or 1.4, but D, 10 cos r is the same as the multiplication. So the cos of r, do we have cos? Cos of r, we have it done, is 3/5. And we're multiplying, so it's 10 over 1. 5 into 10 goes 2, so we get a 6. Notice we have sine squared on the r. So that really means the sine of r being squared. This is the way we write the trig. We put the square in here. That is the same as that. So let's do the sine of r. The sine of r is already done, 4/5. And we're going to square it. So that's 4/5 times 4/5. So that gives us 16 over 25. This is cos squared, so that's the same as the cos of s squared. So let's get the cos of s. The cos of s is 4/5. Already done, so we don't have to. So we get 4/5 times 4/5. So that's 16 over 25. Two answers are the same, and this is, if you want to write little equals going down here, you can. We got the tan of r is the same, tan squared r is the same as the tan of r squared. So the tan of r, do we have the tan? Oh, tan of r is here, so it's 4 over 3. So it's 4 over 3 squared. So it's 4 over 3 times 4 over 3, and that's 16 over 9. H, we have the, let's fill in the tan of s and the cos of r. Do we have the tan of s? No, we have to go and get the tan of s. So here's s, tan is opposite over adjacent, so it's 3 over 4. The cos of r is 3 over, cos r is right here, 3 over 5. And that's over 1, and that's over 1. 4 into 20 goes 5. 5 times 3 is 15. 5 cancels into 5 once, so we get a -3. So that gives us 12. And so notice, when I did this, I filled in I filled in tan s and cos s. And remember, the order of operations here is that I have to multiply this one and this one before I subtract, because of PEMDAS, P-E-M-D-A-S. Inside the brackets, I don't have to do anything. There's no powers. So I have to multiply these two before I subtract by the order of operations. And here I have a bracket and a square root side. So I have to do the cos of s first. The cos of s is 4/5 plus the tan of r. Do I have the tan of r is right here? Yep, this is 4 over 3. So the cos of s, just to make sure, 4/5, tan of r, 4 over 3. And BEDMAS, I have to simplify the inside of the brackets first. So let's see. Common denominator for 15 and 3, for 5 and 3 is 15. So I'll multiply this one by 3 over 3. Multiply this one by 5 over 5, because the common denominator is 15. So that gives me a 12 over 15 plus 20 over 15. And I have to obey PEMDAS. I have to keep emphasizing simplifying the inside. Common denominator is 15, so that gives me 32 over 15, and I squared, so that's 32 over 15 times 32 over 15. 15 got a 3 and a 5, so 32 don't have a 3 or 5, so we can't simplify. So what is 32 squared? So you take the 32 and you square it on your calculator, and you get a 1024. 15 times 15 is 225, so you can leave it as a fraction. It says a fraction in simplest form, so we're okay as a fraction. Tan of r, let's do this one. So notice I obeyed. I had to do the inside of this completely before I could square it. Because of PEMDAS, I have to do the inside of the bracket and then the exponent after. The tan of r is 4 over 3. Times the tan of s. The tan of s is 3 over 4. And 4 into 4 cancels, 3's cancel. So we get 1 over 1, which is 1. Okay, I have a multiplication. So I fill in all these first. So the cos of r is 3 over 5. Times the tan of r is 4 over 3. Subtract the sine of r. Sine of r is 4/5. Sorry, the sine of f. Oh, we gotta be careful. Where's f? The sine of f. I don't have an f here, so I must mean the sine of r. There's supposed to be an r there. How come I got an f there? So the sine of r is 4/5. Sorry about that. Again, one of those errors. Don't know where my mind is when I'm writing down some of these, but I mean, how can I get an f? F is not in this triangle, so that must represent r. And the sine of s is 3 over 5. So I have them all filled in. I have that little area there, that's an r. And I have to obey PEMDAS. I have no brackets to do. I have no exponents, so I have to multiply before I subtract. So they cancel out to give me 4/5. And they don't cancel out. So the sine of r is 4/5. The cos of s is, the sine of s is 3/5. So that's right. No cancellation here. So that's a 12 over 25. Common denominator for 5 and 25 is 25. So I multiply this one by 5 over 5. 5 times 5 is 25. 5 times 4 is 20. Subtract 12 over 25. Common denominator is 25. 20 minus 12 is 8. 8 is even. 25 is a 5, so no common factors. So that's the final answer, 8 over 25. And as you can see, manipulation with PEMDAS. And practice means let's work these out, see how you're going to do. Here we go. We have, let's see. First of all, I'm doing the trig ratio, so I'll do SOHCAHTOA, Sakatoa. Very important. And I have to do the right triangle because I have perpendicular at C, so that's angle C, so that's the A, and that's the B. There's the perpendicular at C, and the tan is opposite. Let's put opposite over adjacent right here. So in relation to angle A, opposite is right here. So that's a 12, and adjacent is right there. And if you memorize the ratio goes 5, 12, 13. Now you do your Pythagorean and work it out, but that becomes a 13. 5 squared is 25, 12 squared is 144. 25 and 144 is 169. Square root of 169 is 13. Because I have it memorized, 5 and 12 gives me a 13, then I don't have to work it out. You can, but there's no need to if you know it. So we have that. So let's work these out. The sine of A sine is opposite. Sine is opposite over hypotenuse. Opposite over hypotenuse is 12 over 13 times the cos of A is cos is adjacent over hypotenuse, so it's 5 over 13. So when you multiply that, you get 60 over 169. Done. And we have the tan of A. Tan is opposite over adjacent, so that's a 12 over 5 divided by cos of A is 5 over 13. So that gives me 12 over 5 times the reciprocal of 13 over 5. So tan, just to make sure, tan of A is opposite over adjacent. The cos of A is 5 over 13, so that gives me 13 over 5. And 12 times 13, and 12 times 13 gives me a 156. 5 times 5 is 25, so there it is as a fraction. And number 3, 26 sine B, that means 26 times sine B. So the sine of B, sine is opposite over hypotenuse, so it's 5 over 13. So that's 26 over 1. 13 goes into 26 twice, so that gives me a 10. And number 4, cos B minus sine B. Here's angle B. Cos is adjacent over hypotenuse, so it's 12 over 13 minus sine B. Sine is opposite over hypotenuse, so it's 5 over 13. Common denominator is 13, subtracts 12 minus 5 is 7. And we have sine squared A is the same as the sine of A squared. So the sine of A, do we have sine A? Sine A is 12 over 13. So 12 over 13 times 12 over 13 gives me 144 over 169 when I multiply. Number 6, cos squared A is the same as the cos of A squared. So the cos of A is 5 over 13 plus 1. So I filled it in. Now I have to do PEMDAS, P-E-M-D-A-S, always P-E-M-D-A-S, there it is. So I have to, can't work out the bracket, but I have to work out the power. So it's 5 over 13 times 5 over 13 plus 1. So that's 25 over 169. 1. So that's 25 over 169. 1 is the same as 169 over 169 because you have a denominator of 169 here. So this has to be a 169. So that gives me common denominator of 169. Add those up and I get 194. And number 7, 13 cos B. What is the cos of B? Do I have cos B? Cos B is 12 over 13 plus 39 cos A. Cos A is 5 over 13. Okay, and we're multiplying, so we cancel the 13. 1 times 12 is 12. 13 cancels into 39, 3, so it gives me a 15, so that gives me a 27. So notice I've made the problems up, so there's cancellation going on, because I have to, and I forgot, I'm going ahead of myself. Remember PEMDAS, after I fill in cos B and cos A, I have to multiply these two by PEMDAS, because I have, brackets are simplified, I got no powers, so I have to multiply these two before I add. Got ahead of myself, make sure. Sine B is 5 over 13 times tan A. Tan A is 12 over 5. And we're multiplying, So when I multiply fractions, I should try to cancel. 5 into 5 goes once, 5 into 5 goes once. So that gives me a 12 over 13. Notice when I multiply fractions, I try to cancel top to bottom anywhere. And number 9, I have to fill in the tan of A. The tan of A is 12 over 5. Times tan B. Do I have tan B? Nope. So the tan of B is, tan is opposite over adjacent, so it's 5 over 12. 13 sine. I could put brackets on these too if I wanted, so it's just a multiplication sign like that. And sine A is 12 over 13. So PEMDAS, all brackets are simplified inside. I have no exponents, and so now I have to multiply this one and this one. So 12s cancel, the 5s cancel, and I get a 1s when I cancel. So 1 times 1 is 1, minus 13 over 1 times 12 over 13, 13s cancel. So I get a 12, and 1 minus 12 is a negative 11. So I've done extra questions on the trig ratios and extra on the PEMDAS. And don't forget to memorize your Pythagorean triples. There's some common Pythagorean triples. If you like my video, click the like button, the subscribe button, the notification bell, because there are more videos coming. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.